Hello students, how are you all? In this session we are going to learn Lewis dot structure of element, that is how to represent a Lewis dot symbols for elements. That's what we are going to learn. So actually the Lewis dot structure, it belongs to valency electrons. Based on the valency electrons only we can write the Lewis dot structure for any of the atom of a particular element. For example, now I am taking boron as an example. Boron belongs to which group? Actually it belongs to third group. So boron will have 3 valency electrons. How many electrons? 3 valency electrons. So to write the Lewis dot structure of this boron atom, you just write these 3 valency electrons around the boron. So this is the one electron, and the second one, third one. So this is what the Lewis dot structure of boron element. Similarly you can write for the other elements. Let's take the carbon as an example. See, this carbon belongs to which group? This belongs to actually fourth group element. So the carbon will have 4 valency electrons in its valency shell. So write that 4 electrons around this carbon. So this is what the Lewis dot representation of carbon element. Okay. Similarly, you can also write for the nitrogen atom. See, nitrogen belongs to which group? It is a 58 group element. So you will have 5 valency electrons. So write that 5 valency electron around the nitrogen atom. Okay. First, write over here 1 and 2, 3, 4. Here 4 we have written, but how many valence electrons are there in the nitrogen? We have 5. So to balance that one more electron I am writing over here. So total 5 electrons are represented with the dot symbols around the nitrogen atom. So this is what the Lewis dot representation of a element or atom of particular element. See, here the students, they may get doubt. For example, if I do not remember the group number of that element, how would I represent the Lewis dot symbols? Simple. See, for boron belongs, actually boron belongs to third group, that you don't know, for example, but you may know the atomic number of boron atom. So just write the electron configuration according to atomic number. So as atomic number is 5 for this boron atom, we just write the electron configuration 1s2, 2s2 and then 2p1. So in this, what is the valency shell? The last shell is known as a valency shell. This is the principal quantum number here, n is equal to 1, and here in the both cases, that is n is equal to 2. Here n is equal to 1, right? So in both cases n is equal to 2. Hence this is the last shell. So the last shell is also known as a valency shell, and the electron present over here, the electrons are valency electrons. So 2 plus 1, 3 valency electrons. How many are there? 3 valency electrons. So that 3 valence electron we have represented around the boron atom. Okay. Similarly, we will write the Lewis dot structure for oxygen element. See, oxygen belongs to which group? Actually, it belongs to 6th group, right? So hence you will have how many valence electrons? 6 valency electrons. So how would you represent the Lewis dot structure? Write the oxygen atom and write these valence electrons around the oxygen. First you write the 4 electrons, 4 sides. Now how many are left? 2 electrons are left. So that 2 electrons you can pair up with either of the electrons, no problem. See, my choice is I paired up here and here, right? Now there are 6 electrons around the oxygen. This is what the Lewis dot representation of atoms or element. See, in this case also, if you do not remember that oxygen belongs to 6th group, simple, what you will do, you know the oxygen atomic number, that is 8. So write the electron configuration according to that. 1s2, 2s2 and 2p4, right? So now let's say for example this is the oxygen nucleus. Around this nucleus there is a shell, n is equal to 1 shell. So the first 1s2 will come over here, and the next shell is there, n is equal to 2 shell. These two 2s2 and the 2p4 both will come over here. Now this, from this nucleus, this is the last shell. So this last shell also called valency shell. So the electron present in this shell are known as a valency electrons. How many are there? 2 plus 4. So totally we have 6 valence electrons. So these are the electrons we have represented around this oxygen. So how will you select the valence electron, students? Either you can based on the group number you can select the valence electrons, or by writing electron configuration, the electronic configuration, and then the total sum of electrons which are present in the last shell, that is valence shell. In this way also you can select the valence electrons and write down these valence electrons around the particular atom of an element. So first you can write the four sides like this: 1 2 see 1 2 3 4, and how many are there? 6 actually. So you can write the other two electrons either of this side, then 6. This is what the Lewis dot structure or symbol somebody says. So students, till now we have seen that how to write the Lewis dot structure or representation for atom of a particular elements, right? So now in the next video we are going to discuss how to write the Lewis dot representation for molecules, like for example ammonia molecule, or you can take H2O molecule, or different molecules. For this molecule, how we have to represent this dot structure. That's what we are going to learn in the next video. And thank you for watching. Please like this video and share this video and subscribe this video. Students, based on the previous lectures, I would like to ask a question, that is what is the shape of this molecule? What is the shape of this molecule, and what kind of bond angle is present in this molecule? Please comment your answer in the box.